Good morning, everyone. Happy Tuesday. Welcome to the webinar. Thank you for joining. Hopefully everyone is doing well. My name is Matthew Dombrowski. I'm a pre-sales engineer with Fiplex Communications. I will be your presenter for today. And the purpose of today's webinar will to give you an introduction to Fiplex programmable active crystal filter devices and the different applications in which they can be used for. All right. So this webinar will be relatively short. We're just covering just the single product line, the active crystal filter product. During the webinar, all of the attendees will be muted, and at the conclusion of the webinar, I'll answer any questions that you might have. So feel free to type any questions in the message area on the right-hand panel. In the GoToWebinar panel, there's a question section. Feel free to type any questions throughout the webinar, and I'll try to answer them along the way or at the conclusion of the webinar. All right, so let's get right into it. So what is a programmable active crystal filter and why should we use it? All right. The active crystal filter, or simply ACF for short, is a unique device used for filtering of interference in the VHF and UHF bands. So the ACF can be used in several different applications, but generally speaking, it's used to clear the reception for a base station receiver. All right. So it's best utilized in highly congested RF environments in order to provide better reception and improve the signal quality when interference is present. Right. So modern receivers are much more sensitive in our broadband, allowing a wide band of interference through to hit the receiver and cause performance degradation. Modern receivers also, they do not allow the use of a built-in pre-selector filter to reduce the overall received noise. Also, there are currently no spectrum allocation rules in the the VHF bands, which leads to having transmit channels very close in frequency to receive channels. And furthermore, the RF spectrum is becoming more and more congested over time. So to solve these issues, you can implement an active crystal filter. So only your desired channel or only your desired channels will pass through these devices to the receiver. So the programmable active crystal filter can be used in many different types of buildings and structures where there's a lot of interference present, right? But airports are a very good example due to having the limited space and not allowing for tall towers to be built throughout the area of the airport. All of the transmitters and receivers are usually located on the control tower. All right, so this can cause a lot of interference to be present at some of the receivers, and you can easily clean the reception by using an active crystal filter, so only your desired channel will pass to the receiver. And if you look at this picture here, you can see all the different antennas on top of the control tower at this airport here. Okay, so the ACF is designed for use in the aeronautical bands, which range from 118 to 137 megahertz. They're also designed for the VHF band and for the UHF band. So it's a crystal-based filtering system, which provides a very sharp brick wall type filtering response. It provides outstanding rejection to interfering channels with greater than 30 dB of rejection to adjacent channels and greater than 60 dB of rejection to semi-adjacent channels, right? Also, there's a built-in highly linear low noise amplifier with a user adjustable gain control to prevent having any additional loss in the system. And the unit is software programmable and tunable in the field using the provided USB cable that comes with the unit. The center frequency can be changed, right? So 12.5 kilohertz bandwidth is the standard bandwidth, but we also have options for 25 kilohertz and 50 kilohertz bandwidth. The tuning step size would depend on the frequency band. The step size for the aeronautical band is 3.125 kilohertz. For VHF, it's 1.25 kilohertz, and for the UHF band, it's 6.25 kilohertz. Right? So there are also two programmable attenuators built in, one for the input and one for the output. These are used to prevent saturating the input and controlling the output and can be set to provide up to 15 dB of attenuation each. Right? So there are also 2 power supplies in the unit for redundancy. So should you lose your primary power supply input, the unit will continue functioning on the second power supply. There's also a built-in monitoring system which provides dry contact alarm output. And the unit uses SMA connections for the input and the output. All right, we also provide 2 SMA to N-type jumpers with each ACF. So you have the option to use N-type connections instead as an alternative. Okay, so here's an example showing an RF spectrum that does not, have proper filtering. There are many interfering channels surrounding the desired channel shown in blue, right? So you can see all the interfering channels. And this is our desired channel shown in the center in blue. So all of these undesired channels will cause the receiver to perform poorly and have bad quality on the desired signal. So by implementing a programmable active crystal filter, you can filter or reject all of the undesired channels and clear the reception of the receiver. And as you see in the picture on the right, this is the spectrum after the active crystal filter, and you can see all of the adjacent channels, all of those interfering channels in orange have now been rejected or suppressed and are no longer causing an interference issue at the receive end. Okay, so next we'll go over the different applications for the active crystal filter. The most typical applications are shown on the screen here. So the active crystal filter can be used at a repeater site that uses a common antenna for transmit and receive. So in this application, an ACF is installed in between the base station duplexer and the receiver in order to filter out the undesired channel. All right, so your receive signal comes into the antenna, it passes through the receive side of the duplexer, then it would be filtered by the active crystal filter device before being sent towards the base station receiver. Okay. The second application is below at the bottom here, and that second application is basically showing that this is a type of application where the receiver does not share a common antenna with the transmitter. So you have separate antennas for transmit and receive, right? And the receive has its own antenna. So in this case, you would simply install the ACF between the receive antenna and the base station receiver to provide spectrum filtration. Okay, so Fiplex also manufactures a unique device called the transmitter bypass device that can be implemented and will allow the use of Fiplex active crystal filter in half duplex and simplex applications. So again, this is for applications where the transmitter and receiver share a common antenna. The transmitter bypass unit will connect the active crystal filter when receiving signal, providing filtration. Once the transmitter becomes active, the device will then switch and bypass the active crystal filter unit. So the transmitter bypass has low insertion loss and provides a very high transmit to receive separation because it essentially disconnects those paths. And all DC and RF jumpers are included with the device. So here's an example of the transmitter bypass and the active crystal filter applied together, right? So both devices are installed in the system as shown in between the base station antenna and the base station transceiver, right? Now, when transmit power is off, right? So when the base station is not transmitting, what it does is the transmitter bypass will default to listening in the receive path, right? So when the transmitter power is off, the TXBP, the transmitter bypass, connects the ACF to the receive path, allowing the ACF to provide filtration of the signal to feed back to the base station receiver. okay? Now, when the transmit power turns on, whenever there's transmit power present coming from the base station transmitter, the transmitter bypass will, it bypasses the transmit signal to the antenna, providing high isolation to the ACF to avoid damage. So you see when the transmitter turns on, it will bypass the active crystal filter and send the transmit signal directly to the base station antenna. Okay, so finally, we'll go over our active crystal filter application when used in our bidirectional amplifiers, right? So as I mentioned earlier, there are no spectrum allocation rules for VHF, and the UHF band can have some complicated frequency arrangements too, right? This all can lead to complicated frequency pairs that have very small transmit to receive separation, okay? So our active crystal filter can be implemented inside our BDAs to provide very, very tight filtering around the desired channels, right? So we can provide this unique solution for one channel or two channel systems in VHF and UHF bands, okay? So there's no need, what this does is it basically eliminates the need for a split DAS, which would need to utilize separate transmit and receive antenna branches. The ACF allows for the option for internal duplexing, right? When otherwise you would require some sort of customized external filtering or split DAS arrangement requiring separate transmit and receive antenna branches. This solves that issue for one and two channel systems, where normally you'd have to, find another way to solve the issue. We can keep the system duplexed. We can keep it a one box solution, just using a single donor antenna and a single duplex output to feed your DAS, okay? So a very unique solution that we can provide inside our BDAs to provide, custom specialized duplexing when otherwise you would need to, use an alternative type of complicated solution like a split DAS or external filtering solution. Okay, so that concludes our webinar on 5-plex programmable active crystal filter units. At this time, if you have any questions, feel free to type them in the questions area and I'll answer them the best that I can. So I don't see any questions coming in at this point. Yeah, no questions have come in, so I don't want to waste anybody's time and hold anybody up. So thank you for joining and taking part in today's webinar. If you do have any follow-up questions at all, feel free to send an email to myself. My email is shown there on the screen. But other than that, thanks again for joining the webinar and have a great day. Stay tuned. We have, check the webpage. We will be having some certification training next week, and we'll have many, different upcoming webinars on the new Flex products line. So stay tuned to the webpage and email me if you have any questions. But thanks again and have a great day.